Okay, so today we're going to talk about the digital wallets and then especially about the difference between the hot and cold wallet. So, yeah, basically, like the crypto wallets are the digital platforms where you can manage your cryptocurrencies, crypto assets, and tokens, right? But there are two different types of wallets: the hot wallet connected to the internet, and then the other one, the cold wallet, is not connected to the internet. I think that's the basic difference based on my research. But then the hot wallet has been gaining some bad rap because it has been associated with lots of attacks, such as like the Coincheck attack in 2018, and also the Bithumb attack in 2019, and then like lots of people actually attribute the attacks to the vulnerability of the hot wallet. So I think it will be interesting to talk about like the differences between the two, and then like why one is online and one is offline. So what functions can they perform? Absolutely. And about the vulnerability of the hot wallet. So yeah, so first of all, can you help us understand what are these two wallets, and then what the functions they perform in the app?
Okay. Yeah. So first of all, we need to understand that wallet here refers to the ability to move cryptocurrencies, right? Or to digitally to crypto sign request in a blockchain. So the ability to do this is given to a user by the possession of what is called a private key. The private key is a secret string that is equivalent to a password conceptually, that you use in the mathematical function of signing the request for a transfer. So let's say I want to send you 1 Bitcoin. I need to use my private key to make a mathematical calculation on the request and then broadcast to the blockchain, to the peer-to-peer network, the request, so that it's gonna get executed. Obviously, as soon as somebody come in possess of my private key, they can spend my Bitcoin, because there is no other identity check beside the private key. So the only things they identify the owner of some funds, some cryptocurrency funds, is the possession of the private key that allow to sign the request of a transfer. So this private key needs to be protected very well. This is why people use hardware token, the hardware wallet. For example, this is a Ledger Nano S, and the private key stay inside here. So when I connect to the computer, only the request, there is a display here, I can see what I'm signing. When I authorize to sign, the mathematical operation that authorizes the transfer of Bitcoin happening in here, and only the finished signature goes out. Meaning that if somebody put themselves in the middle between my computer or even hack my computer trying to steal funds, unless I'm distracted, I don't read well what I'm signing. But if I do it properly in the hardware wallet, I only sign what I see. So the person that hacked my computer or is in the middle in my telecommunication can only stop my request to reach the blockchain. So if I want to send 1 Bitcoin to you, maybe it's not going to happen, but they cannot modify or sign in my behalf. Okay. This is what is more understood as a cold wallet. So it's a wallet that requires human intervention to make an operation and a transfer. Yet there are websites that need to do constant blockchain operation. Is it to constantly send small funds to many users? Let's think about the exchanges. In the exchanges, everybody wants to withdraw their cryptocurrency from the exchange anytime they want. So to do this, the private key is not protected and kept away from the computer, but is left in the computer in a configuration file where the computer has the code to sign and do the transfers that are needed. Sometimes it's kept in an hardware device, but this hardware device doesn't require humans to verify and submit, but the computer can automatically process the transfer. Now, if somebody managed to hack this computer or hacking the computer and steal the private key, obviously can spend the funds that are attached to that private key. That is called a hot wallet. It's hot because it's constantly used and is in a place that is a little bit risky. So some exchanges, for example, do the payout twice a day, and humans verify every single payout before doing it, and they keep a cold wallet, and they don't allow automatic transfer. But many other exchanges or other websites, other online services, they constantly do operations, means that the private key is somewhere that can be possibly attacked and taken in order to do operation. And this happened many times, right?
Yeah, so in a sense, the cold wallet is safer because like the private key is on a separate device. Is that correct?
There is still always a human error in between.
Okay.
Meaning, at the beginning, the wallet had no display. So you need to trust what you see in your computer in order to sign it. So you still need the hardware device that probably need to press a button or put your fingerprint or whatever, but you don't see in the hardware device what the hardware device is signing. You only see it in the software that runs your computer or on your mobile phone. If the software is hacked or is fake, you think you're sending money to a certain address while you're sending much more to the thief. So these were not safe. Then that's why all the wallets now have a display so that you can read in the hardware device what you're doing, and you don't have to trust what you see in your computer, on your mobile phone, or whatever it is that you are sending the data to.
Yeah, and the private key is of course like different or unique for each user, right? Like for each individual user.
So private key works like this. There is what is called a seed. Usually is 12 or 24 words of any sort, like car, oranges, fatigue, whatever it is. And these words represent each number in base 1600, I think, system. So when you put 24, you have a 24-digit number on base 1600. Means that before you go to digit, you need to go to 1600 first digit. So it's like binary use only 0 and 1, right? So it goes to digit immediately. We use base 10, means we go from 0 to 9, and then we need to go to digit. This seed phrase use base 1600 circa, I think, and which means there's still single digit until this 1600. So the number that you reach with a combination of 24 word out of 1600 word dictionary is a huge number, so huge that is very hard that duplicate collision happen, rather than somebody can guess one that is already being used by somebody else. From this seed, we can create a lot of private and public key pairs, which means that one single seed can generate thousands of different Bitcoin addresses, for example. Each address has its matching private key. Private key cannot be changed. Means that once the private key gives their address, that's it. There is no like a password that you can update the password. You throw away, move the funds in another address, and it's going to have a different private key. So much that Bitcoin is made so that every time you spend Bitcoin, you don't only spend the one that you're sending to the other person, but you spend also the rest of the Bitcoin, which are sent in a new address. So you don't expose or use the same address more than once. So the private key are used one time, two time only. So.
And then there's a private key and there's a public key. Like, what are the difference between the two?
The public key is the address that you show to everybody, right? So if I want you to send me some Bitcoin, I need to give you my public key. The public key is cryptographically connected with the private key. So if you send me Bitcoin to a certain address, I can only spend those Bitcoin using the private key of that address. and so on and so forth, right?
Okay. Yeah. And what is the role of digital signature in the wallet's functions?
Is the authentication of the owner of those funds. So in order to make sure that from this address going out in an authorized way, the request of move the coins out has to be signed with the private key of their address. So whoever has the private key of an address owns whatever their address has, and can sign, because they can be used also to sign a piece of text. So if I want to prove, for example, we need to make it work together, I want to prove to you that I have the funds for this work, I can show you an address where the funds are there. And then I can sign a message that says, hey, this is Roberto, and those are my funds. And I sign with the same private key. This is not requested to move money anywhere, but allow you to see that the signature is authentic, means that the same private key, as it signs a message, can also send the request to move the funds.
Okay. Yeah. And my next question, how do digital wallets work together with the blockchain platforms or infrastructures? So mainly they are used to manage transactions or the flow of funds in these apps.
The extent meaning of the wallet, but no more in the cold or hot wallet. A wallet is an application for a mobile phone or a computer or a web application that allowed to see all the past transaction I did. You're allowed to see many other information which are taken from the blockchain. Unfortunately, most, if not all, of the available wallet, they talk with the central server. So they're not really part of the centralized system. There is a central server managed by somebody that provides this wallet all the information that need to be displayed. And when the wallet requested an operation like a transfer, are collecting the request from the wallet. So they can easily connect the request in terms of which cell phone you're using, because they know it, because you have their application, which is the identity of the person, pretty much connected to the transfer that you're making using the wallet. A good wallet should connect to the peer-to-peer network and broadcast directly to the blockchain without middlemen. But it becomes very slow, it becomes not 100% reliable, but that is really the centralized wallet.
Okay, and then why, if it's not latched on to like a central server, then it becomes slow? Why can't it just be relayed directly to the blockchain then?
Because usually a central server is a fast one-to-one connection, can keep a pipe open between the wallet, while node of a blockchain, the provider that is reading cannot be a single node, because if it's a single node, it can be compromised and give false information. For example, if I know that your wallet connect to my node, I make you look like you got the funds because that's what my node is going to tell your wallet. You read some information which is not accurate. While to work with the centralized system, your wallet should connect to several nodes and keep changing the nodes that is connected to. Ask the same question to 3-4 different nodes and see if the answer match. If the answer doesn't match, then ask 2 more. If the answer match, then trust the answer from those nodes. So it's an operation that is a little bit more complex, but eventually in fully decentralized system, that's how things should work, without a central server that sits in the middle between the wallet and the blockchain.
Okay. Yeah, and then it's moving toward that direction.
DecBC does this. DecBC.
Yes.
If it works, when it works, but the wallet connects directly to the blockchain, doesn't go through a central server.
Okay. And then like the hardware, what's the function of that hardware really in like the digital wallet?
In an hardware wallet, the function is to put a gap between where the private key is stored and the mathematical operation the private key does to sign, and the part that can be compromised by hacker attacks, virus, or whatever else. Yeah. So even a Ledger Nano itself has a USB port to connect it to the computer, right?
Yes.
And inside there are two devices, if you want, two different pieces of computer. One that just sign, and one that handle the display and everything else. So that even if somebody make an application for the ledger, has no access to the part where the private key sits and the seeds has been memorized and so on and so forth. In this way, is very secure. So even if somebody find a way from the USB port to attack the device, they will not be able to find and access the private key. This is why many people that build hardware devices and as is not very well prepared, they can make nice wallet, but they are very weak when it comes to potential attacks, because they put the private key together with the rest of the code, and anybody making an application can steal the seed or various private keys.
Okay, so that makes the wallet vulnerable to attacks, more vulnerable. Yeah.
Correct.
Okay.
Let's consider one thing, which is very interesting. All this lesson learned by this sort of underground community that's pushed blockchain until today. The now also big corporation, financial institution use these things. But in the past, it was really just this underground movement. These lessons learned there are now applied in other places. For example, the digital signature released by government, which does pretty much exactly the same thing, like when you digitally, cryptographically sign the request for transfer Bitcoin. I cryptographically sign my rental contract with the government, electronic ID card or digital signature that they give. But those cards that provide the signature do not have any display to show me what I'm signing. I need to trust what I see in my computer. So if I have attacked your computer and I have compromised the software that is combined with your government ID card, you may think you're signing a document of not much importance, and maybe you're actually signing a power of attorney to me to access your bank account. Then I go to the bank, I take your money, I have a legal document signed by you, but you don't know that you signed it because your card has no display. There is the chip. The chip contains the private keys issued with a certificate from the government, so it's everything legal, but it doesn't show you what you're signing. So as soon as government realized this, as much as the blockchain world realized this 10 years ago, then they're going to start producing an hardware device that allow people to see what they're signing with the government issues card. And this is something that is very, very much needed and important to do.
Yeah. Okay. And my next question is, why is you already explained why the hot wallet are vulnerable to attacks, but then how does these attacks, because these are big ones, right, like the Coincheck and with the Bithumb, how these attacks have affected the popularity, or maybe I should say like adoption of the hot wallets, or and then are some hot wallets better designed than others? So
those are pieces of software. It's not a wallet that you buy at the shop, right? So how it's being coded depends on the capacity of the developer that created that, right? So understanding very well the risks of memory leakage, of many other things, is very important when coding something that has a very high responsibility on finance and other things. Unfortunately, today developers are too spoiled with a lot of platforms that let them do a lot of things without understanding what happened to the lower core level of a computer, exposing software to weaknesses, even if it's not directly the fault of the developer. Probably is the weakness of the platform that they used, and things don't get updated in time, etc., etc. So it's very important to understand how a piece of software has been coded, how which has the hot wallet inside per se, how whatever management of private key or seeds that is done at code level is done in such a way that cannot be tricked to release information or to sign at will whatever people wanted to sign.
Yeah. And are there lessons we can learn from this, like big attacks in 2018 and 2019?
Let's pay attention not to confuse those attacks with the DeFi attacks that have been taken. So attacking a smart contract on Ethereum platform is all another thing. Attacking an exchange like Mt. Gox has been the first important attack where the hot wallet has been taken over, rather than many other. There are some ridiculous ones. For example, an exchange, sadly in Italy, was leaving the balance written in the JavaScript of the browser. And when people were requesting to withdraw the balance, it was checking only on the client side in the browser and not on the server side. So people could simply edit what it was written in the JavaScript in the browser and keep taking out money that they didn't have. Obviously, this means the developer was really incompetent, and the supervisor that was supposed to check the code was really incompetent or didn't exist in the first place. And and they got attacked, but they are the first to blame, in my opinion, right? Sometimes for example, there is some vulnerability in the operating system that expose possibility to take memory dump from application running, and you're using Linux, and until this thing has been discovered and patched, you are vulnerable. So it's very difficult to say what are the risks. Even somebody make the code perfect, it can always be a way to attack. More popular something is, more prone is to be attacked, right? Because as where the effort is worth to be put.
Oh yeah. So like what you're saying is that like the blockchain infrastructure, it's like a complex thing. So like an attack cannot only just be blamed on like the wallet, or because it involves like many different elements in how it runs.
Let's not forget that the wallet is a centralized part of the whole system. Okay.
Okay.
So
yeah,
blockchain, there is no history of attack except some consensus like proof of work that has been gained to make double spending. Obviously, but it's the first and it's not safe. But blockchain in general are quite safe. So when you run an exchange with a hot wallet, the exchange is centralized. That's why everybody wants to move to decentralized exchanges, which are a reality already today, but they're not very well appreciated or deployed. Then the mechanics are different. But wherever there is a wallet, you have a central point of operation. Is it an exchange, a user, or is not the blockchain? Is that what is needed to talk to the blockchain? But to ask a question or ask, the blockchain to do something, but that's centralized.
Okay. Yeah, and then as you were saying before, so now like we're moving toward a direction whereby the wallet can actually communicate directly to the decentralized system without the central point. Okay, so an attack is just one kind of disruption to the function of the wallets, but then, and maybe like most extreme, I should say. But what technical glitches or like what operational problems which can happen to the wallets when like they manage the transactions and the exchange?
So the wallet itself, in the act of signing a transaction and broadcasting it, is the delicate part, the delicate moment, right? There are many ways that this thing has been attacked or forced to sign something, even if you don't know the private key, but you know how to send the request for the application to sign a transfer of 50 bitcoins to you. Who cares about the private key, right? So you can directly attack like things like that. Then there are many other things that the applications that manage hot wallet do. So if it's an exchange, there is all the internal running of the exchange. There are many other weaknesses that are not directly connected to the hot wallet that can be exposed and that people can use to generate a request of a transfer that is not legitimate. For example, the example I was giving before, people just modify the balance in their own browser and the exchange just send them the funds, but they didn't hack the hot wallet, but they managed the system to send out wallet request that was not legitimate, and that wallet obey. So many times it's not the hot wallet that is attacked, but the system that manages the hot wallet is now built in a way that is safe. As simple as that.
Okay. Yeah, and then like if you log into or sign up to an NFT marketplace, you will also have to create your wallet. So it's like to manage the payment and
90% of the case is going to be Metamask, which is a plugin that allows to interact. And Metamask is a wallet, so we manage a private key and sign. But you can connect your hardware device to Metamask. So you have your hardware wallet, which does the signing. Metamask does the token with the blockchain and the browser. And in this way, you are more protected, let's say.
And then I heard like lots of people talking about MetaMask, and then it's also very popular. Can you tell us more about like the advantages or the strengths of the system, and then how it becomes like a popular wallet?
There are many other alternatives to MetaMask. MetaMask is just the most popular because it's been there and it's not very well designed. I think there are a lot of things that can be changed, but nonetheless, it does all the things you need to do. It's a plugin that you can install in your Google Chrome browser. I think is there also for Firefox and whatever other browser has plugins. Brave, which is a browser that support privacy, etc., has it already embedded. It has a modified version they use for itself. They're allowed to tip people to do a lot of or get paid to watch advertisements, etc. So it uses these functionalities. Supporting the fact that the browser protects the area where a plugin works means that the plugin memory cannot be seen or read by other plugins or by other web pages, etc. If it's coded properly, it's safe because it shows you what you're doing and allowed to bridge that with different applications that there are online. I use it. The creator and inventor of MetaMask lives in Bali, which is an interesting thing. I think lives in the south of Bali in Canggu, and is a nice application. Is a nice wallet that is necessary to interact with many websites that do NFTs or they do crypto.
We should invite him or her then to our podcast.
Absolutely.
And finally, DecBC, like it's a wallet or like it's a type of a coin, right? Like a cryptocurrency. But tell us about DecBC. Like what kind of wallet does it have, and like what functions?
DecBC is a blockchain, right?
Blockchain.
Which has its own wallet, and a wallet that is devoted to a particular blockchain need to have the transaction types support, so that the blockchain has. So most blockchain, they can transfer funds. So that's the wallet is set to look how much balance you have, how much you want to send to who. That's as simple as it is. But there are blockchains that support other functionality like voting. So
Oh
the
yeah.
wallet need to have the user interface to allow user to cast a vote and cryptographically sign the vote and send it over, or messages, or I don't know, marketplace, or purchase or offer of exchanges, whatever it is. The wallet need to have all the user interface and the capacity to validate all the transactions that the blockchain has and support. So more complex the blockchain, more complex the wallet, more things to do.
Okay. Yeah, I think I have asked all my questions. Do you have anything more which like to add which I haven't asked?
I think there is a lot of evolution to be made also on wallets as much as on blockchain, but they are growing together. It's important that the general public has something that they can trust that protect them from malicious actor on the other side.
Yeah. Okay, Roberto, so thank you. And then let's see you again next week.
All right. Thank you very much.
Yeah.